Yes, dear students, before going to the Niels Bohr's model, we need to discuss the nature of light. Light energy is the form of energy which is emitted from any hot body once it is emitted and propagates through space. According to James Maxwell, it is propagated through space along the line of propagation in the form of waves. Hence, the James Maxwell theory is called wave theory. Wave theory of light. These electric and magnetic fields are mutually perpendicular to each other and having same velocity, that is the velocity of light. Both propagate along line of propagation. Now we need to discuss the properties of a wave. Any wave which we can witness in the form of water wave, it disturbs on the water surface. So the properties of wave properties of wave. One is the velocity, velocity of light. Its value is 3 into 10 power 8 meters per second. So this is the velocity in vacuum. Quite high velocity. It also depends on the density of the medium. The velocity slows down as density of the medium increases, but change in value is negligible. For all practical purposes, we use the light velocity as 3 into 10 power 8 meters per second. To amplitude A. Amplitude is the maximum displacement. This is the crust, this is the trough. Maximum displacement, maybe the distance of the crust, maybe distance of trough. There is the amplitude. Next property we'll see the wavelength. Third one is the wavelength, lambda. It is the distance between two successive crusts or troughs along line of propagation. I repeat, it is the distance between two successive crusts or troughs. Its units are distance units, of say angstrom units, microns, millimicrons, meters, centimeters, nanometers, and picometers, etc. Oh, these are the different units. 1 angstrom is equal to 10 power minus 8 centimeters. 1 nanometer is equal to 10 power minus 9 meters, like this. So that is the wavelength of light. Next is the frequency. Fourth property is the frequency. frequency nu. As per the definition, it is the number of waves passing through a point along line of propagation. Actually, the units are cycles per second, or simply per second. The equivalent term is the hertz. H. You can express in megahertz, gigahertz, etc. So the relationship between nu and lambda is the inverse relationship. Nu, which is lambda, this is the proportional constant. C itself is the nu into lambda. That is the relationship between wavelength and frequency. Next is the wave number. Nu bar. It is the number of wavelengths. It is the number of wavelengths per unit distance along line of propagation. Naturally, it is based on the definition. What we can say is the nu bar is 1 by lambda. So units naturally per distance, per centimeter, per meter, per angstrom units, etc., per micron, etc. These are units. Now together these relationships, you see that nu is equal to C by lambda, C nu. In other words, nu is directly proportional to the nu bar. So these are the properties of wave, say electromagnetic wave. And with this background, then we will go to the one important observation around the year 1900. Black body radiation. What is the very definition of black body? Black body is one which acts as a perfect absorber and emitter of light energy. That is the very definition of the black body. A perfect black body is thought of a metallic halosphere. It is a metallic halosphere. metallic halosphere having inside rough coated, rough black coated surface. This object is the pinhole. This almost acts as a black body. A black body which should absorb the whatever the light which enters into it. Then that we can explain. Assuming that a ray of light is allowed, through this pinhole, then once it enters through this pinhole and strikes on this black coated surface which is rough in nature, where part of its energy is absorbed, remaining part is reflected and reflected and reflected and reflected. After taking infinite number of reflections inside, its total energy of the light is absorbed. In that way we can explain it acts as almost a perfect absorber of light energy. Similarly, it can also act as the perfect emitter of light energy. Taking the same metallic halosphere, and when it is heated to a given temperature, it starts emitting the light energy. The emitted light energy is monitored through this pinhole, whatever the light energy which is coming out, and which is monitored through this pinhole, the number of wavelengths, and frequency of each wavelength were recorded around the year 1900. And such data, experimental data, was presented in the form of a graph. This is the intensity of light and wavelength. The pattern of black body like this. This is a T1, T2, T3, T4, T4, T3, T2, T4. This is the pattern of black body radiation. Pattern of black body radiation. What we can understand from this graph, as temperature increases, the amount of light energy also increases. The area under each curve tells about the amount of light energy emitted. That is one observation. Second observation is, as temperature increases, number of wavelengths emitted also increases. Second one. Third one is what? This is the lambda max. Lambda max means the wavelength at which maximum intensity of light is emitted. As temperature increases, lambda max shifts towards lower wavelength regions. So these are the observations which we can infer from this graph. Many scientists, Wiens, Rayleigh and Jeans, many scientists attempted to explain. They failed to explain the complete pattern of black body radiation. And one scientist from Germany, Max Planck, he could explain the complete pattern of black body radiation. The success of his theory was due to different idea he has taken. With that idea, he is able to explain the complete pattern of black body radiation. What is that idea? The discontinuous nature of light. That was a quite revolutionary idea which was pronounced by the Max Planck first time. Hence, the year 1900 is said to be the turning point for the science. And earlier science development was said to be the classical science. 1900 onwards, the scientific development is said to be the modern science. That was the revolutionary proposal which was made by the Max Planck. The very failure of explaining the black body radiation by earlier scientists was only due to adopting the wave nature of light. Just now I have explained the light is emitted and propagated in the form of waves, continuous waves. But this man, Max Planck, proposed a very completely different hypothesis. According to his hypothesis, light energy, any black body, any hot body is the electromagnetic source, light energy source. That, according to his hypothesis, light energy is emitted discontinuously or discretely. First thing, discontinuously or discrete. First time, the discontinuous energy packet or bullet or bundle is called quantum. The energy of the quantum, that is E, energy of the quantum is directly proportional to frequency of light, where the proportional constant h is the Planck's constant. Whose value is 6.6 into 10 power minus 34 joule per second. Joule second, not per second, joule second. Or 6.6 into 10 power minus 27 erg second. Erg second. That is the proportionality constant. With this idea, so light energy is emitted discontinuously. Each discontinuous energy packet or bullet or bundle is called quantum. Quantum energy is directly proportional to the frequency of light. This is the energy of one quantum. This is the energy of n number of quanta. So plural form of the quantum is a quantum. N is the number of quanta. So this was the idea. It's quite a new concept. This is the corpuscular nature of light. Corpuscular nature means discontinuous nature. Corpuscular nature of light. So proposal, okay, good, well and good, and he able to explain the complete pattern of black body radiation with these proposals, and he was quite successful man. And now the new idea of light we have to accept. One is the wave nature of light, another is the particle. This is the particle nature of light. So unless until it is experimentally proved, then only we can accept this hypothesis. So this Planck's hypothesis becomes theory once this idea was experimentally proved. That was made by Albert Einstein, from his photoelectric effect. That we'll discuss in the next class.